Like I said, I'm just going to go over a simple ERC20 contract today to give you guys a better idea of what you can use a contract for. ERC20 tokens is a standard that was devised probably a couple years ago. If you go to, let me actually, what I'm going to do here is, you do need to get Geth for sure. Let me pull this over here though. Definitely need to have Geth. So I'm going to pull this over here, and you see here, it's the EIP 20 token standard. All it is an interface for how to implement this on a smart contract. So it denotes a couple things, a couple methods. It's got name and a couple variables. That's it. So what does a basic token on Ethereum need to have? It needs to have a name, a symbol. So that's a ticker symbol that you see on any price list of tokens that you've seen, like coinmarketcap.com or something like that. How many decimals the token has. Fun fact about Ethereum, they don't do floating point on Ethereum. So if you want to have a contract or a token with 18 decimal places, the actual supply of the token is going to be, if you want to have 1 million supply of a token, it's 18 plus 9 zeros for 1 million. So just keep that in mind if you're ever using a token or something. Total supply, which is just the number of tokens, right, that you deploy. And I'm just going over this as basic, the interface methods, right? So balance of, transfer from, which I won't go into deeply, and these things called events, which help client apps read what's going on with their contracts easier, basically. And it goes over some implementation, things like that. But yeah, that's a basic ERC20 token. So if we want to actually implement one of these, let me open up Atom. Cool. If we want to implement an ERC20 token, so you can see conceptually how it works and how you could potentially see how to store data and access data on a smart contract, and hopefully you can leverage that to build something cool. So first thing I'll do is let me create this on my directory. So let's go to Ethereum. Okay, cool. So I make my directory with ERC20. I'm going to use truffle, and I'm just going to do a truffle init, so that way truffle's all set up in my project and I don't have to worry about it, right? You have to have pre-installed truffle as well. What I'm going to do before I do that actually is I'm going to run geth for Rinkeby, which is the testnet for Ethereum, one of the test nets. You have a question? Okay. Well, let me know if you have any questions, because just let me know. So I'm going to run geth -- Rinkeby, and then -- RPC -- RPC API, and then with these things I want to access. So Web3, DB, personal, Eth, and net. And what this is going to allow me to do is it's going to allow me to access this JavaScript console down here when Rinkeby is actually running. So I'm going to run this right now, and it's going to start running. It's going to do its magic. And I'm going to look carefully for the IPC endpoint open right here. And it's going to give me a path. I'm going to copy that path, and I'm going to go down here. You can see that. It's going to say geth attach IPC : and I'm just going to copy paste that path right there. So what does that do? Now I have a JavaScript interface that is actually going to be able to interact with the blockchain that I'm downloading on my computer as it's going, right? So it's importing the blocks, and it's just catching up with the blocks right now. No big deal. It should catch up in a couple seconds because I just caught it up. So now I've got the full Ethereum chain running. The Rinkeby chain, if you do a -- fast, it'll do a fast sync for the blockchain, and it'll sync up in less than an hour. I think it's pretty lightweight, so it should sync up pretty quickly. Yeah, you can see I'm caught up because the number of blocks that are coming here are in order. So it's just coming in by normal order of blocks, roughly every 15 seconds, right? So 69, 70, I should get 71 next, right? So yeah, there we go, 71. So, and now that I've got the JavaScript console, I can take a look at some things like, I think it's personal.accounts, web3.eth. There's a whole set of Web3 calls that you can do, and I'll send you the documentation. But so if I do web3.eth.accounts, I'll actually see the accounts that I have with my testnet. So these are two addresses that I have here. I think if I do, I don't remember the call, web3.eth.getBalance, I pass in the address of my account. And cool, it passes me an actual balance in way, which is the minimal, the smallest denotation of ETH there is. So, so yeah, that's kind of like, I wouldn't be able to run this if I wasn't running Geth right now, right? And this is the testnet. I also have the same thing for mainnet on this computer, so I can run mainnet Geth and get my mainnet balance that I have on this wallet on this computer, right? So, so yeah, and that's I'm also going to use this interface to deploy the smart contract, right? So, which gets a little tricky. So first thing, let's go back to the project. I'm going to do a truffle init, and that initializes the project with truffle and all the magic that truffle does, right? Cool. If I do an ls, you'll see some stuff there that shows up. And I'm just going to go ahead and open it in Atom, which is my preferred, there we go, cool. My preferred IDE of choice. Visual Studio has an awesome one too from Microsoft, so whichever one you guys prefer. And I'm just going to go over here. Truffle makes a migrations contract, which helps me, which basically it migrates the contracts for me, so that way I don't have to do it. It just does it very easily, magically for me. And it has a migrations JS file, which I'll have to make one specifically for the contract that I create as well. So this migrates the migrations contract. I'll also make one for my other contract that I decide to create. And we got a couple config files here that basically denotate, okay, which network do I want to deploy this contract to? So which I'll go over in a little bit. Actually, I'll do that right now. Hold on a second. So what goes in this truffle.js file? Well, I'm just going to copy paste this over here so you guys can see it a little bit easier. Cool. So a couple things here. What network am I going to denotate? This is if you use Ganache, this is the default for Ganache. So you don't have to, and in fact, Truffle just automatically defaults to Ganache. So you just have to do truffle migrate, which I'll show you in a minute. And it'll just automatically, as long as you have, kind of like how I have my blockchain running over here, if you have Ganache running, and you do a truffle migrate, it'll deploy the contracts to Ganache as well. If you want to deploy it to Rinkeby or mainnet, you have to just say, hey, where do I want this to be pointed to? So mainnet, their network ID is 1. Rinkby's network ID is 4. And you can name it whatever you want. Rinkeby is the name of the network, so obviously that makes sense. You want to point out the address that is going to deploy the contract, right? So since I created an account here, and I'm forgetting the command to create an account, because when you first run Geth, you're not going to have an account there. So you have to go into the JavaScript console and actually make the call to create an account. And Geth does all the cryptography for you and everything. You don't have to worry about it. It's going to make a public key and a private key for you. So that's super helpful. So I'm going to grab my address here, 5v0, and I think it's different. So let me, yeah, cool. And the gas is just kind of like a gas limit to the maximum amount of gas that you want to deploy the contract, right? So and you can have as many configs here as you want for any network. You can even have a config for your own private network if you create it, that your own fork of Ethereum. So, so that config file is done. So cool. And actually, let's go see the Web3 stuff. So Web3 commands, documentation. Cool. So if you go to the Web3 documentation, you can see. So cool. Where's accounts? Cool. So this will give you all the different kinds of accounts, or all kinds of different calls that you can use with Web3, right? Which is really helpful. So yeah, and cool. So I've got that. Now I'm going to use Truffle to just create a contract, a really simple one. So it's literally Truffle create contract, and whatever you're going to call it, I'm going to call it ERC20. And goes and creates the ERC20 for you with the default stuff. This is a version of Solidity. I'm going to bring this up to 18. It's up to like 24 now, but I think my version is around there. I haven't updated it in a while. So just like any object-oriented language, this is what creates a contract, the contract declaration. And then what the actual contract is called, ERC20. This part here, this is a constructor function, which gets called once. So when you deploy the contract to Ethereum, the constructor function gets called once, and it never gets called ever again. So you can kind of hard code variables and set things up in the contract right when it gets started, and then that way when people interact with it, you can then it just never gets called again. So yeah, there's that. So how would we build this interface for what an ERC20 is? What any token, right? What the basic interface for any token would have. First thing we want to have are the state variables. So the general format for this is you want to have the state variables at the top of the contract. You want to have any events after the state variables. And then you'll have the constructor function, and then you'll have the meat of it, right? The functions that actually people use to call in the contract, and then any getters at the very end, kind of a thing. So, or sometimes people put them in between. It's really up to you. So the first thing I'm going to do is create a mapping, and I'm going to have it take in an address and return a uint 256, right? I'm going to make it public and call it balances. So what does this do? If you have a contract with a bunch of tokens, you need a way to keep track of everyone's balances, right? So my address here, if I were to pass this address in to this function, which creates a getter for me automatically, by the way, so I can actually call this and it'll return me a number, right, automatically. Defaults to 0, by the way, not an empty memory, but it'll default to 0. And it'll return to me a number. So that's how we kind of keep track of the balances of the entire token of this contract, right? So if I have 10, I pass it over to someone else. It'll subtract 10 and add 10 to the other side, right? I'm also going to do the public supply, right? So I'm just going to declare a normal uint 256, make it public, and call it total supply, right? And total supply is pretty self-explanatory. So for example, I could set the total supply in the constructor function is a good place to do it, equals 1 million tokens, right? Now remember, there's no floating point on Ethereum, so I would actually have to add 18 more zeros if I wanted 18 decimal places, right? Or I could add this keyword, ether, and it creates them for me. So that way it's a little bit easier. So yeah, I'm saying 1 million quote-unquote ether, but it's just 1 million tokens. And anything you see on any Etherscan or any of these other websites, it's based off of this nomenclature. So yeah. And yeah, and then I want to set the balances, right? Like who is going to have the balances when this contract actually deploys? Because right now the contract has it, but that wouldn't be very helpful if I'm deploying some token to incentivize people, right? Unless you can get it from the contract yourself. But what I can do is I can say balances, and since it's a mapping, you pass in the key that you're going to set the variable to, like this, and you want to say message.sender. Message.sender. What is message.sender? Message.sender is the address of the person calling the contract. So, or function. In this case, I'm deploying the contract, so my address is the message.sender. So I'm setting the balances of the address of the whole contract to the total supply, right? So basically, I'm saying I'm creating a coin. Let's call it Tampa Bay coin or something, right? And I'm setting me as the owner of all of them, right? So you can imagine if you have allocations, you have some investor, you can say, okay, this address, you get this amount, kind of a thing. Or if you want to give coins to people for incentivizing them to do stuff, you can just kind of do that in the constructor, or do the transfer function yourself as well, manually. Correct. Correct. Exactly. 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 Correct. 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 Exactly right. What else? So I skipped up a little bit. So cool. What a couple other things? Yes. Yes. Yeah. Yeah. So that does. So the message.sender is basically saying the address of the person who is. Yeah. This is a global. This is kind of like a global thing. So there's a couple of globals. So you can grab these things from Ethereum, like the current block, for example, like how much gas was used, the signature. You can grab if someone's sending Ether, the amount of value inherent in that transaction, and if there's any data in that transaction as well. So, which is pretty cool. And I believe, okay, I thought it was a set balance, but yeah. And also, if you want to call this contract I think it's this dot balance, like you can grab the balance of Ether in this current contract, right? Or this dot. In fact, I think you can do address as well. So if you want to get the contract of this address, if you need it at any point in time, kind of a thing. So what else? In the ERC20 standard, there's a couple things. There's a name, so we'll do string public name, string public symbol, and uint 8 public decimals. Right? So here in the constructor function, we want to say name equals, I don't know, Synapse token. Right? So that would be us naming the token. So this is what any website would read from. Right? So what's the name of the token? Right? What's the symbol? Equals, let's say it's I don't know, SPT? It's like a cool, whatever, right? That's a symbol. And then the decimals, since we're using Ether here, it's 18. So the Ether thing is 18 decimals. So you just want to hard code it and say 18. Make sure that matches. So you could say 10, but it would actually be 18, right? So this is just for ease of use for other people, right? So you want to make sure when you're building your apps, the stuff that you want readable from your contract are there as state variables here, right? So strings, numbers, mappings, things like that, right? Yeah. So that's the basics of getting it started, right? So what are the things you need to have a token, right? Well, you need to be able to grab the balance of that token, right? So, and you saw that in the standard, balance of was one of them. So you want to do function balance of, and what's it going to what are you going to pass in? Well, you're going to pass in an address, and it's going to return a uint of the balance of the token, right? So you want to say address, and you want to say who is the owner of the address. So it's just a nomenclature thing, and it's a constant. So we're not changing any state in this function call. If you're not changing any state in a function call, you want to highlight it with a constant always. Else it won't work. So, and you want to have it returns uint 256, and we're just going to balance, and we're just going to return balances and pass in the address that was passed in the function. So this function will return to you the balance of the contract, or of whatever address that you're passing in. This is a free call. Like Ethereum, people, you say everything takes 15 to 30 seconds. Because this is a constant, this is just a read. You're just returning data. It's actually free and instant. Because I'm running the latest state of the blockchain on my computer, I know what the latest state of the blockchain is. So I can do a read and actually get that data instantly. The only thing that takes time are the writes. Make sense?
Okay.
Cool.
Yeah.
Cool.
That, yeah.
Yeah, it makes things a little bit easier. Not everything's going to take time.
So even if I don't have the latest block on my machine,
you can cache data. You can do all sorts of magic to kind of show things, right? Which is good.
So it would take significantly less time than write.
Writes still take the standard block time. So writes will take about 2 blocks, so 30 seconds. Yes, but reads are instant, almost instant, and free. And they don't cost any gas, they don't cost anything. Cool, so that's the function balance of. Well, we also need to be able to send tokens from one address to another, right? So this is an actual state change of a contract. So we're going to call it transfer. And what do we need for the transfer? Well, we need who is sending money, or who's receiving the money, and how much money are they being sent, right? So, yes.
Who pays the gas? Is the person calling the data, or is the person that's owning the contract?
The person calling the function. So the contract owner spends a lot more gas getting all this stuff set up on the network. So the cost of deploying an entire contract is much more expensive than just a simple method call. If I'm going to transfer tokens from me to you, it's going to cost me about 40,000 gas, which is at current prices like 1 cent, something like that, in real money terms, to do that transfer, right? And I could send you, $1 million of some token, right? And it would still cost me 1 cent. But I just have to have Ether in my contract to be able to do that, which is one of the biggest user experience problems with Ethereum right now. It's like you want to build a new app with new users, but every time that user creates a wallet, to be able to interact with your dApp, they have to have Ether in it. So that's a big problem with Ethereum.
Yeah, I was just going to say, what if, going back to our original problem that we're trying to solve with this, say I hook it up to a Fitbit or whatever. So that person with the Fitbit, we're expecting them to have the Ether wallet and have Ether in it and pay every time?
So there's some upgrades. For example, Ethereum is going to be allowing the contract to be able to spend on behalf of a user later this year as one of the updates.
That's what I was going to say. So say...
Right now it's not, this is how early we are, by the way. It's not even there yet, right? So...
That makes a lot of sense because say I'm the app owner.
You would like...
I want to pay for my users to
correct.
use it.
But think about it. What if I'm a malicious user and I just want to spam your contract? Then the business owner is then spending a lot of money in gas for fake fraudulent transactions.
I mean, you can think the same way of just like having a server and database. Somebody,
sure.
You're paying for it.
But you can delete you can delete those entries on the server. You can't delete them on here.
But I mean, it's still the same problem with spamming.
Yeah, of course. But these are the kinds of things you have to think about when you're developing for this stuff.
Right.
But for sure, yeah. But yeah, one of the updates with Solidity in the coming months is going to be allowing the contract to pay for the gas. And you can even pay for the gas in tokens, which is really interesting because there's hundreds of thousands of tokens that people have released. And lots of them have real value and real liquidity that people could, for dApps, there's one for prediction markets, there's several for prediction markets. Imagine being able to pay gas in those tokens, It's interesting. So what goes into a transfer method? Well, you have to know who is receiving it, so who's getting the money, so 2, and how much. So we're going to call it value, right? And no constant, because this is a real state change that we're actually doing, so it's going to cost real money. And it's going to return, and we're just going to say true or false. So bool success. Cool. So, yeah, no worries, man.
One other question. So, could you bypass that by so say I have my data from my Bitcoin, can I send that to the owner's server, then that server,
yeah,
then do the post?
That'd be a great solution. It's a little bit centralized, right? But that's okay, I think.
Yeah, I guess so.
Now, by having that data in some hashed format on the smart contract, maybe there's some value that can be derived from that, you as a business owner.
Right, but I mean, couldn't it be hashed on the client, and then that hash be sent in?
Absolutely.
And then that hash could be then sent here to the contract?
Correct, yeah. And that would preserve some privacy, right?
Right.
So that'd be good. Absolutely. 100%.
Yeah, I mean, then you would still just be at the mercy of the app owner to make sure they didn't screw up your hash or whatever.
Correct. Now, what if I was getting some token for giving you that hash, right? So I'm willingly doing this as a customer because I know I'm going to get some token back. And then the provider or the business owner has a bunch of data that they could potentially use to sell, right? With your permission, right? And every time they sell that data, they buy $10 worth of that token on an exchange and burn half of it. And then, they keep the other half as revenue. So then I'm getting some token in return, and it's going up in value because there's less tokens in existence, right? If it's actually worth something. As like an incentive mechanism, right? To give out my data. So using like a deflationary model. Or you could use a mint model. Like you could actually type a mint function that quite literally increases the total supply, and that's it. Which there's lots of people doing stuff like that too. And Zeppelin, if you see, I'll show you Zeppelin in a little bit. They have all that stuff there for you, actually. So burning and minting, those are the two functions that you could do. I'm doing a transfer function right now. So quite literally, to do a transfer, it's balances, message.sender. So this is the person calling the function, right? The address calling the function, right? And doing minus equals of the value. And then we're going to do the same thing, but for the 2, but plus equals the value. That's it. That's how you transfer. You just change the actual balance of the ledger. This is the contract in itself is a ledger by itself. Now, the problem with this is there's some checks that need to be made. Because what if you have 0 tokens? Right now, you could just send in whatever you want.
Yeah, you could have a negative balance.
Correct. So you can do a check if balances of message.sender less than the value. Just do a simple revert. And that just cancels it before anything happens. And the user gets their gas back.
So could you have the concept of a negative value?
You could, but
Negative balance?
that would be kind of worthless, I think. You could. If you could.
Negative balances in my bank account.
Yeah, that's a good point. You're right. That's a good point.
So if you're
You
writing
could.
this for a bank.
Yes, if you wanted to code that.
Okay.
Yeah.
But I mean, you're using a UN, so.
And at the end,
Well, obviously, right, you can't send a negative value.
yeah.
But that balance could that, you have that as a, what kind of data type is the balance?
So balances is the mapping I did up here. So it takes an address and it returns a uint.
So that can't be.
I'm sorry? It could, yeah, it could totally be negative. Absolutely. Yeah. There's tokens that add in a whole bunch of different governance. So if there's the tokens that add in the ability to freeze a given account, you can't transfer tokens anymore, sorry. There are tokens that add in minting and burning at will. It's up to you. Now that, correct, it depends. Correct. I mean, you wouldn't want, anyone to just mint tokens, willy-nilly, or if you want them to trust you, and they see the code and they're like, wait a second, why are you putting a mint there that you can create any token? You know what I mean?
But that's not the idea, is because it's transparent, like you'll see what
Correct.
you did,
Correct.
and you know part of that.
Correct.
Part of
Exactly.
that. But there's no one saying that.
Oh, you can do whatever you want. Yeah. And if people believe in you, if they trust you, then that's all, which is fine. So yeah, that's a basic contract. This is missing a lot of stuff, but I just wanted to go over this kind of just basic. Yes.
If the function requires gas, you have to put a keyword, and then function
No. So the gas comes in every time you change state. So here you're changing state. This is a series of opcodes that cost. It's hard coded in. These things cost a certain amount of gas. So the compiler can estimate, based on your opcodes, how much gas any given function call is going to cost. This is very simple. This is not going to cost much gas, but you can imagine if you're doing a for loop, iterating over an array, that could get really expensive, really fast, right? So that's stuff you have to be careful of. You don't want to. You want to try to avoid any recursion or any loops like that, because that can get really expensive really quickly.
do you want to have a condition where the recipient's address doesn't exist to avert it?
Yeah, exactly right. So I think it's if I remember correctly, if 2 equals 0x0, it'd be something like that. So that way, if the address is empty, you can't send anything. And this is an effect. Like if you don't have this, every token has a burn, if you will, because you can send addresses to, or you can send tokens to an empty address, and then they're technically burned, right? So yeah, that's basic. That's a basic contract. What I want to do is deploy it. First thing I'm going to do first, I'm going to try to deploy it on Ganache, so you can see that, and then I'll try to deploy it on the RINC-B test network afterwards. So what I'll do is, there we go. Okay, cool. So I'm going to run Ganache CLI. So I'm running a fake blockchain on my computer. This is great because all the transactions are instant, and I can just go ahead. If I can do a truffle, if this works first time, I'll be very happy. Truffle compile. That's okay. I think it'll still migrate. These are just, yeah, they're just warnings, I think. So that's fine. Not a big deal. Cool. So it should work. Let me make sure I have everything. Oh, nope, it's not going to work because I don't have my the migration file for the ERC20 contract that I created. So I'm going to do truffle create migration. ERC20. Let's call it deploy user. Deploy ERC20. Oh shit. Cool. Created it. What I'm going to do is I'm just going to copy paste this over here. Just edit it. So I'm going to call this ERC20. ERC20.sol. So .sol is .solidity, by the way. That's the kind of file it is. And there's a deployer called the .deploy, which we're just going to deploy the ERC20 object that I created up here, right? And yeah, cool. So when I compiled it, it actually created this thing called an API, which is the interface of all the functions and methods of my contract. And you're going to need this to be able to deploy it to the testnet as well. And you can grab that here. So I want to end. Where is it? Right here, right at the bytecode. So, and I'll show you. We're going to use this in a little bit too. So I'll show you. But I think if I do truffle migrate, you'll see up here some transactions actually happen, meaning it deploys to the ganache, to my personal blockchain. Cool. Took 4 blocks in my fake blockchain. It's there. Instead of using this CLI or this JavaScript console, I'm going to use the truffle specific JavaScript console. So truffle console. Cool. And web3.accounts. Cool. So these are the accounts that come with the truffle console, right? Let's see, I should have the ERC20 contract. I do. So if I do .deployed, I can see all the information in the contract. So Web3 creates this contract object for me that allows me to interact with it. And it's this custom contract object. I can do that, and I can then play around with it, right? So let me make it in a little bit easier way. I can do ERC20.deployed. If you know JavaScript, this might look familiar. And I'm just going to set a variable, so I'm going to call it SNT. I forget what I called it. What did I call it? SBT. Cool. SBT equals instance. So I'm just going to set SBT to the contract, right? So I can do SPT dot balance of, right? Pass in the first address, because Truffle automatically uses address 0 in the array to deploy the contract. And so web3.f.accounts. I'll show you a trick in a second. Cool. So it passes me the value of what I set it at, right? Let me do this. So I'm going to do account. Let's do sender equals web3.f.accounts. So I'm just setting the sender to the first one, right? And we'll do receiver web3.f.accounts, and we'll send them receiver. Cool. Great. So I can do a transfer function, right? So spt.transfer. So it's 2. So I want to put receiver and how much I want to send them. Let's say 10 tokens. And it should. These are reads that are happening up here. When I do this right, it should actually go to the next block, right? Cool. It did. So it tells you some information. How much gas did it cost? 49,000 gas. The block number 5, transaction hash, and all this information, right? So if I do SPT balance of, and I pass in the receiver, it's got 10, right? So that's kind of how you interact with the contract that you deploy to Ganache. Yeah. So now, how do we do this on a real blockchain, right? There we go. So I'm going to do this again. Run that there. I have to reset this over here, down here as well, for this new session, right? And I can get out of here as well. Cool. So I'll give it a couple seconds to catch up. But yeah, you want to add a, like every time you deploy a contract? No, it's fresh every time. Fresh every time. No, Rinkeby is a real blockchain, so it, yeah. But you can deploy a new contract, and it'll have a new address, just like Ganache would. Ganache technically has a new address as well. So, cool. I'm caught up. So I'm gonna do geth migrate network. I'm gonna specify network and I called it Rinkeby, right? Rinkeby, right? So what this should do is deploy my contract directly to Rinkeby. There's one thing though, you have to unlock your account through your geth JavaScript console. So you have to do personal, actually let's say 3.f. Actually, I think it's f.accounts. Cool. So I'm going to do sender, I'm going to do the same thing I did before, equals f.accounts and 0, and receiver f.accounts 1. Oh, oops, yeah. Cool. So I have those variables, and I'm going to have to unlock my account as well. So this is, when you do the RPC API, these are the APIs you're like unlocking. So you unlock Web3, which allows me to call these methods. I'm going to unlock the personal, or unlock the personal, so I'm going to do personal.unlock account. And I want to unlock the first account because that's the one that's actually doing the transfer. That's the one doing everything. So sender. Cool. And there's no passphrase, I think. Cool. And another way to do it, actually, let me show you this way because this is a little bit better. Like this. So I'm going to copy this over here. I'm going to put in my password here, which is empty, and then I'm going to put in 0, which allows me to unlock the account for the entire session that I'm going. Because it gets really annoying having to unlock it every time you do a transaction. So, cool. So that's unlocked. So now that it's unlocked, this should work. I should be able to, let me just double check everything, yeah. Should be able to deploy the contract. So what you see up here is you'll see contract deployed, and you'll see the migrations do its thing, and hopefully this works. Oh no, that's not right. Huh. Oh, not geth. Huh. Okay. So let me get back in there. So I believe it's truffle migrate network Rinkeby. I think that's it. Cool. So now it's working. I submitted the contract to Rinkeby. It's going to take a little bit to get mined, but what you can do is you can take your address. So if I take my sender address, which is the contract that created it, I go ahead and put that here. I go over to Etherscan, so I go rinkeby.etherscan.io. Right? I pass in the address that deployed it, and you can see here it's got a pending contract. It's trying to mine it, and it's just going to take a couple seconds for it to get mined. So, yeah. So let's see if hopefully it gets mined. It's going to take a little bit. And you can see here I have 14 fake Ether on my account here as well. So, Yeah, it'll tell you here, and you'll see it. So it's deploying the migrations contract, and then it'll deploy the ERC20 contract. Does all that stuff make sense? Yeah. I'm sorry? No, no, it's fake ether. So you want to go to a faucet. So you want to go to faucet. Rinkeby? Oh, absolutely. I would not recommend you do anything on mainnet. That would be expensive. So faucet.rinkeby.io, and if you pass in a social network URL, like I used Gmail or Google, whatever the
Google Plus.
Google Plus, yeah, because no one looks at Google Plus, so I just yeah. So just use Google Plus, or I think you can use Twitter too. But you just put the address. All you do is you put the address of your Rinkeby account that you created, and it'll fill it for you instantly. So actually, let me see if I can get it to work, so I can show you guys. Cool. So let me put this up here so you guys can see it. So I went to my Google Plus. Cool. So as you can see, all I use Google Plus for is my test of my faucet stuff. So I think B0, so that's this one here. I don't even know how to get the thing, but let's find out. Cool. This is the link to the post. Put the URL here. Give me Ether. I'm going to take 18 ETH. Oh god, I hate these. Cool. So funding request accepted. If I refresh this, the contract's already done, right? Hopefully it takes just a couple seconds to get, but yeah. Yeah. Cool. So I got 18.75 Ether in my test account. So that's how you all can get Ether in your test account. Every 3 days. I mean, you're not going to go through all that Ether, so trust, yeah. No, it's going to cost a fraction of an Ether to run the contract.
So, you said there's 4,000. Is that 4,000 gas?
I'm sorry?
You said there's 4,000 gas to run that contract?
No, let's see how much it costs. We can see that here. Deployed the contract.
Yeah, gas use is 27,000. Is that 27,000 today?
No, so gas is a different thing. Gas is a formula that Ethereum uses to determine how much things cost.
This is vibrate.
It's kind of like looking for like computational power.
Here it is.
to actualize the
Yeah. So this was the actual contract. This one cost 582,000 gas, which is, I mean, it's still not that much money. Like this would cost, this is still pretty cheap, all things considered.
So you multiply that by the gas price,
Correct.
and that gives you the actual cost,
Which is in G-Way.
500ths of a
Correct. So this is the gas price. This is how much it costs. So at this point, if it's real prices, Ether's around $500. This costs $5. If it's half of.
Is that
Oh no, more than that.
Michael, could that be estimate for the main blockchain?
Yeah.
So it'll be about the same.
Yeah. Correct. So I've got the contract deployed. Got it deployed. Now Truffle returns you the address of the ERC20 contract. It's right here. Right. So what's next? Now how can I actually interact with it? This is where Ganache saves your life, so you don't have to do this every single time.
So do you need to develop that camera
Yes, they're separate. Ganache and Geth are separate. I mean, you don't need Geth to do smart contract development. Like, you could do it completely on Ganache, and you'd be completely fine. But if you want to do kind of like a real test, like with kind of real latency of submitting transactions, then you could be running Geth on your own thing. Line breaks. There's this awesome tool called removelineBreaks.net, which I'm going to do. What I'm going to do is I'm going to take the ABI from my ERC20 contract and just format it properly so I can paste it in. So I'm going to remove the line breaks. Have this, which is it's just JSON. If you guys see, it's quite literally it's just JSON, right? I'm going to paste this in here, actually down here. Oh, no, I did that wrong. Okay, so I'm going to do ABI equals, I'm going to set a variable, set to ABI, pass in the ABI. So I have this ABI variable with the text. I'm going to do contract equals f dot contract, I think, if I remember correctly. Cool. So now I have this contract object, right? So now I have this contract object that's this Web3 thing that it magically does for me. It's got the skeleton of the smart contract that I deployed, but the only thing is that it doesn't have the address. Because you could point this skeleton to some other contract, but it wouldn't work because it doesn't have the right functions, right? Since I know the contract address that I just deployed right here, So then I'm going to do kind of what I did in Ganache, spt equals contract.at, and quotes, pass in the address, and all of a sudden I have the spt contract that I should be able to access because I'm running Rinkeby on my computer, right? So let's do spt.balance of. Did I set it? I think I set it. Sender. Cool. So it's working. So I deployed it. I've got a balance. This is you have to do a conversion in way, but this is the 1 million that we said that it was, right? So if I want to do the transfer, right? I have the receiver address. I have the sender address. So I'm going to do spt.transfer. Who's it going to? It's going to the receiver. It's going, and let's say 10 tokens again, right? And the trick here is because you're working with the real blockchain, you have to specify who it's coming from in this case, since you're doing like a regular transaction, because you could have many accounts here. So you have to specify who it's coming from. So you want to put this in the squirrely brackets, and you want to say it's coming from the sender. And this should work. So, cool. Transaction submitted up here, you can see it. And if I do receiver, it's not going to show anything. It's going to show 0 because it hasn't been mined yet. So in a couple blocks, once a couple blocks gets mined up here, one's been mined, another one will get mined in a second.
5 seconds.
Oh, it's about 30 seconds. Yeah. Hopefully the next block. Next one that gets sent in. Hopefully it works. Cool. Yeah. So transferred. This was on a real test net. Everything that worked on. Yeah, this is Rinkeby.
So if I go on my phone, I'll see $10 as well.
Yeah. So if I go and I pass the receiver address. And I pass this into Etherscan,
Yeah.
right? Token transfers, I received it, right? So it even reads all the information for me, right? So, and I've got 100 BST, so cool, right? Yeah, so yeah, that was it. that's all I wanted to show you guys on maybe developer tools. I definitely recommend looking into Zeppelin. Zeppelin's amazing for building your contracts and things like that. If you have any questions or anything, please reach out, email, Slack, whatever it is. So, yeah, thank you guys.